In exercise 1, Callie has a choice of 20 flavors for her triple scoop cone. If she chooses the flavors at random, what's the probability that the 3 flavors she chooses will be vanilla, chocolate, and strawberry? Well, the vanilla, chocolate, and strawberry, we want to consider the fact that order doesn't matter and that selecting it, so long as we get the vanilla, chocolate, and strawberry as a group, then that's fine. So therefore, this is a combination. And there's only one favorable outcome where we would get vanilla, chocolate, and strawberry. So when we calculate a probability, it's the number of favorable outcomes, 1, out of, we have 20 to choose those 3 flavors. So when we're calculating it off on the side, just for this problem, I'm going to show you guys 20 choose 3 would be 20 factorial over 20 minus 3 factorial times 3 factorial on the bottom. So when you simplify that, you want to make sure you divide by 17 factorial times 3 factorial. You can even think of 20 as 20 times 19 times 18 times 17 factorial, in which case the 17 factorials cancel out, and you're really dividing by 3 factorial instead. And so when you simplify that out, you get 1,140. So there's only a 1 out of 1,140 chance that she would get vanilla, chocolate, strawberry. So Danny has a dog walking business serving 9 dogs. If she chooses 4 of the dogs at random to take an extra trip to the dog park, what's the probability that Fifi, Gordy, Spike, and Fluffy are chosen? And again, for these 4, it doesn't matter the order. So there's only a 1 favorable outcome in which of the 9 dogs, those 4 are chosen. So if we again simplify out the 9 choose 4 factorial, or 9 choose 4, we would get 9 factorial over 9 minus 4 factorial times 4 factorial. So that would simplify out to be 9 factorial over 5 factorial times 4 factorial. There's also a factorial button on your calculator. So you guys are more than welcome to use that. Make sure that you put parentheses around this as you simplify. And we should get 126. So there's a 1 in 126 chance of selecting those 4 dogs from the 9. Why don't you guys hit pause and then try 3 and see if you can set it up. A restaurant critic has 10 new restaurants to try. If he tries half of them this week, what is the probability that he will choose the Fish Shack, Carly's Place, Chez Henry, Casa de Jorge, and Grillarius? And so that's a total of 5 since that's half. So hopefully you guys figured out one favorable outcome in which in the 10 restaurants we choose those specific 5. And the order didn't matter. The answer should have been 1 over 252. So on the number 4, again, try to hit pause and see if you can do this on your own. Okay, so Emily is giving away part of her international doll collection to charity. She has 20 dolls, each from a different country. If she selects 10 of them at random, what's the probability that she chooses those countries listed? So there's one favorable outcome out of 20 countries that can be chosen. She picks the 10 listed above. And we should have gotten 1 over 184,756. And the last one, it's a little bit more complicated, so we'll do this one together. So on this one, Josh is going away to football camp. He needs 8 t-shirts. At home, he has 20 t-shirts to choose from. 8 of his t-shirts and Baron t-shirts, the others are 8 of his t-shirts and Baron t-shirts, the others are not. What is the probability that he randomly picks 4 Baron t-shirts and 4 non-Baron t-shirts? So I believe there's a repeat here. I think 8 are Baron t-shirts and the others are not. So if we have a total of 20, how many of them are not Baron t-shirts? So this we can deduce there's 12 that are not. So when we have 2 subgroups in which we have to select from each one of those subgroups, our top changes in that we have to find all of the possibilities for each one of those subgroups having the selection made that is required of the problem. So what is the probability he chooses 4 Baron t-shirts if he had a subgroup of 8 Baron t-shirts? So the combination for that, because order doesn't matter, is 8 choose 4. And then what we do is we're counting all the possibilities of a favorable outcome. So the other part of this is that we're multiplying it by the other event, which is that there is 12 non-Baron t-shirts to choose from and 4 are chosen. Okay, and then below that, so that's our favorable outcome, we divide it by the total number of t-shirts selected, which is 8, are chosen from a total of 20. So 20 choose 8. And so we should get 70 times 495 on top, divided by 125,970. This probability, or this chance, is 0.275, or 27.5%.